So now we're ready to do the alkynes reactions. First, let's talk a little bit about the structure and geometry of alkynes. We find that these triple bonds consist of 1 sigma and 2 pi bonds. Triple bonds are shorter than single or double bonds. They have more S character to them, more S characteristics, and the carbons are sp hybridized. They are reactive as bases, and they will find that they will function as nucleophiles. In industry, acetylene is used in welding. That's a triple bonded structure. Frog toxin, synthetic birth control, both have triple bonds. So let's name these guys. This compound is a pentane with an A. This compound is 1-pentene with an E. And this last compound is 1-pentyne with a Y. The naming steps are going to be the same as the naming steps that we've used previously. First, we're going to have to identify and name the parent. The parent will have the triple bond, so it has to contain the triple bond. Then we'll identify and name substituents and number the parent and give numbers to each substituent, and then assemble using alphabetical order. Okay. New considerations. What I said up here, the parent bond the triple bond has to be on the parent, and you must give the triple bond the lowest number. So on this example, this would be 1, 2, 3, and not this. So the way we would name this is a heptyne. And it's a 2 heptyne. It looks like we've got trimethyl. So we've got a 5, 5, 6. And I don't know if I have enough space to put trimethyl in here. The 5, 5, 6 trimethyl 2 heptyne. So there are a couple of common names, methylacetylene, diisopropylacetylene, phenylpropylacetylene. Terminal alkynes are monosubstituted. With only one alkyl group, and we would expect them to look like this. An internal alkyne is disubstituted, and we might have something like. It's important that you always draw the alkynes as a linear molecule. I meant to say that at the top, but needs to be linear. Don't ever, let's see this. Do not draw that. Let's make that red and draw a big X over it. Okay, let's look at providing some systematic names here. This would be a good place for you to attempt to name these, and then you can look at my names. Well, we find the first one is symmetric, so it doesn't really matter which way we go. 1, 2, 3, 4, 5, 6 carbons, and we find that it's 3 either way. So this is a 3' hexyne. The next one, we could name it either direction, but if we number it from this way, we'll be giving that methyl group a lower number. So this will be 2-methyl, 3, and it's a hexyne again. Okay. We want to give this triple bond the lowest number, so we've got an octane, so this would be 3-octane. And here, 1, 2, 3, 4. This would be a 3,3-dimethyl, 1-butane. These are methyl groups, and they're on the 3rd carbon. Okay. Draw the line bond structure. Well, we've got a pentane. The way I usually draw these is I know I'm going to need to have a linear structure, so I start with this part. It's going to be this triple bond is going to be on that 2nd carbon, so we know that this one will be 1, that'll be 2, this will be 3, and that's 4. So we've already got 4 carbons on here, and it's a 5-carbon molecule, so there we go with that. On the 4th carbon, we're going to have 2 methyl groups, and we're done. Again, we've got a heptine. I always start by drawing the linear part. It's a 3-heptine, so we do that, we get 1, 2, 3. We know we've got our triple bond in the right position. We need more though. Here's 4, and there's 5. So then we could do 6 and 7. On 5, we have an ethyl group. This is 4, this is 5 here, so there's our ethyl group. And we have a 2,5-dimethyl. So the 5 has a methyl group on it, and the 2 has a methyl group on it. So there we are.